Alright, so let's start the class now. Okay, so the first thing I want to teach in this virtual classroom is about rate of change. It's like what I think it's like one of the quite important part in the differentiation chapter. So first, for rate of change, whenever you see rate, no matter you take physics or not, you should understand actually the word rate actually means is something related to time. Alright, so if you want to calculate the rate of change, mean we know this one actually is highly related to the time. Alright, so the first thing over here is the most important like formula for rate of change is like you have a change rule. But before you go to the change rule, I want you to understand what is the meaning for rate of change. Okay, rate of change is something like this. Alright, so let's say we got a circle, and then this is a center point, and then we have a radius. Let's say the radius is 10 cm. Alright, and then I will tell you the rate of change of radius. Rate of change of radius is something like 1 cm per second. Okay, and then I ask you to find the rate of change of area. Find the rate of change of area. Alright, so what is this meaning? Okay, first, whenever you see rate of change of radius is like 1 cm per second means what? Means actually every second this radius actually is reducing 1 centimeter. So like 2 seconds he will reduce 2 cm. So you can imagine if the radius decrease, obviously the area will decrease, right? So you will have something like this. So the area will become smaller and smaller. Correct or not? If the radius is decreasing, the area will become smaller and smaller. So maybe until here the radius only left like 5 cm. Until here the radius only left 2 cm. So you can see the area actually change when the radius is decreasing. Same meaning is the area becomes smaller, mean the radius will become shorter. This is something like rate of change. Means the question might ask, after 3 seconds, what is your area right now? So you have to find your area. So you have to understand what is the meaning for rate of change. Okay, rate of change mean like you want to find how long your radius will decrease in after 5 seconds, or means how small will be your area after 10 seconds. This is something like it's always related to time. Alright, so then we go back to something very important, which I call it change rule. Alright, of course we will go to example later. Not change. It's something very important called change rule. You have to really understand about this formula, then you can easily score very well in the rate of change chapter, mean this part. Alright, so change rule is something like this. Okay, first thing I will call it dy over dt. Mean like every second the y will actually change. No matter it's increase or decrease, we also call dy dt. So dy dt, if I change this one into the word form, I will say rate of change of y. I will call it rate of change of y. Okay, so whenever you see the word rate over here, mean dt. Whenever you see the word rate over here, it will mean dt. Okay, let me use other color. When you see rate, it means dt. Okay, this is something very important. Okay, then I change back to blue. Alright, then I want to write a change rule. The easier way normally I do is I'll draw a line, draw another line, and then this is multiple. And then actually here you have two fractions over here. So over here I will write dt. I will write dy. And then this is, I will write dt. And then on the on this empty area over here, I actually will write something that share in common. So in these cases, I write dx and dx. Okay, why I want to do so? You imagine, if this is something like fraction, you know multiple, if this is multiple, this is dx and dx, actually we can easily simplify it, correct or not? So after I simplify it, this one become 1 and 1, correct or not? Become 1 and 1. So dy multiple 1, I got dy. 1 multiple dt, I got dt. So this one, is it get back dy dt? So mean that this chain rule is work. Alright, so let me undo the thing. Okay, so this is chain rule. However, I must tell you something very important is the y and x, or y and the x, actually they are variable. Variable means what? There can be anything in this case. There can be y toward x, or like area toward radius, or can be volume toward radius, or can be like volume toward x. So y and x, it can be anything in these cases. So you have to very depend like what question want. So if I change y and x to a and r, what will happen? Okay, so you can imagine, if I got area equals to pi r square, this is a simple area for circle. So if I differentiate area toward radius, what I will got? I actually will get 2 pi r. So this is dA dr, right? So dA dr, I will write over here. So if in these cases I have dA dr, okay, what I know is I must have something related to dt. So this one can be dA dt. And then multiple, I say here is dr, here have the same dr. And then the other side, we will write back dt. Okay, this is something we call change rule. Or you can understand, actually you can do whatever you like, not necessarily like follow my type. Okay, let's say I write dA dr here, and then I want to write a change rule. I draw 2 lines, I put a multiple. Here I will write dA, here I will write dr. And then the middle, I must find something the same, which is dt. Because in rate of change, you always have dt. Okay, so yes, you can form the chain rule whatever you like, but you must make sure after the multiple, actually this chain rule is correct. So you must make sure after I simplify this one and this one, I get back the ADR. Alright, if not, if your chain rule is wrong, then your everything will be wrong. Okay, so let's have a look some like real example. It might make you understand this concept better. Okay, so over here, let's randomly take one question. Okay, maybe I will erase everything here because I need some space for, because I think it's quite impossible for me to explain all the questions, so I randomly choose few of it. Okay, maybe I choose the first one because you're like more familiar with dy dx. So this one actually will give you y and x, so you will feel like not so confused maybe. Alright, so over here he said given that y equals to 3x squared plus 4 over x, where x and y are two related variables, so x and y is their variable. He asks you find the rate of change of x. So what is the meaning for the rate of change of x? First, I say when you see rate, you must know this one is related to dt. So rate of change of x, so straight away come to my mind will be dx dt. Some student ask me a question is like, is dt always at the bottom? Yes, in most of the time dt is always at the bottom because it's the rate of change of x, so of course it's dx dt. Impossible you write dt dx. Alright, because rate of change of x, you can imagine, you can memorize something like dt is always at the bottom. Alright, then he asks you to find this one, so we do not have this one. Okay, when x equals to 1, so he gives you some information later, x equals to 1, he asks you to find what is dx dt. So here he gives you some information. If y increase at the rate of 0.5, so So first, y increase at the rate. So if you understand y increase at the rate, actually is mean dy dt equals to 0.5. If you can't understand y increase at the rate, you can get the idea from the unit they give. This is what? This is unit per second, correct or not? Unit per second means what? If unit I use for y, so this one will be dy. And second is used for time, so over dt. Do you see? Unit per second mean dt is at the bottom. You can understand like this if you want. Alright. And then the other thing I must mention in this part is you always must very be careful of the word increase or decrease. If you use the word increase, okay, you can do as usual, which is 0.5 unit per second. If you change increase to decrease, you remember to add a negative into it. Because in rate of change, it's very important that whether it is increase or decrease. So remember, decrease you must add a negative. Alright, so yeah, you can write the unit over here is unit per second. Alright, so now the question asked me to find dx dt, and then I have dy dt, and I realized that I need something else in order to form the change rule. But before that, I try to form a change rule first. So I say if you want to form a change rule, very simple. You draw two lines. Alright, put a multiple over here. Alright, this is dx, so I copy dx over here. And this is dt, so I copy dt over here. Alright, and the middle here, I must find something in common. So in these cases, we have x and we know we have y, correct or not? So here, actually, I will write dy and dy. Alright, and I realize actually I have dy dt, which is 0.5 dy dt. But I do not have dx dy. So what I will do is, I will find dy dx first. Because I know I can easily find this one. I got y equals to 3x squared plus 4 over x. I write in indices is 4x negative 1. So I differentiate this one. I move the power in front and I minus 1. So it will be minus x negative 2. So which is 6x minus 4 over x squared. This is dy dx. But now you will face some problem. You do not have dx dy. You only have dy dx. So what I will do is, okay, I will make it simple for you. I combine everything. So this is over 1, right? I make this one have the same denominator. I multiple x squared. I multiple x squared. So actually this is 6x cubed minus 4 over x squared. Okay, this is called dy dx. So what happens if dx dy? You just flip over the whole thing. Become x squared over 6x cubed minus 4. This is what happens if the question asks for dx dy or dt dx, something like this. When you flip over here, you have to make sure you flip over here. So why I want to like make them have the same denominator, then only I flip, because it's like more secure. Because if not, suddenly you will make some mistake over here. So normally I will make them become a single fraction, then only I like flip over. Okay, so if now I got dx dy, I got my dy dt. I know I can form my change rule. So dx dt, okay, I write again, dx dt over here will equals to dx dy multiple dy dt. Okay, so I got my dx dy, which is this one, x squared over 6x cubed minus 4 multiple my dy dt was dy dt 0.5. And then I give you something very important is, he says what? He says when x equals to 1. So I just wrote here when x equals to 1. Then I can start to do. So basically this is 1 over 6 minus 4 is 2. Multiple 0.5 actually is 1 over 2 also. So you got the answer is 1 over 4, or you write in decimal is 0.25. Alright, so therefore what is my final answer? So dx dt is actually equals 0.25 units per second. Means what? The x actually will increase 0.25 unit for every second. So maybe 10 seconds already, it already increased like 2.5 units. after 100 seconds, it will increase 25 units. Okay, this is the meaning. Okay, so far so good. Got some basic idea on how to solve this question. So if you have no issue, I'm going to move on to the question number 2. I hope like when I discuss more questions, I give you more example, actually can help you understand this one better. Alright, so I'm going to move to like question number 2. Okay, so of course, to make it clear, I'm going to like erase everything here. If you have any question, you can raise hand or you can type in the chat room at the bottom here. Okay, I'm going to erase everything and then I'm going to move on. Why I gotta tick here? Okay. Now, in question number 2, what will happen is, okay, let me change some color maybe. Just do not confuse you. Alright, over here, number 2 now, the radius of the circle decrease at the rate 1.5 cm per second. So first, you must understand the word. What is the meaning? The radius of the circle decrease at the rate. So radius will decrease straight away. The information come into my mind will be dr dt. Because what? Because I see the word rate, I know I should have dt. And then here the first sentence he said the radius of the circle. So I let the radius become r, because this is like something like official symbol for radius. So it's what? It's 1.5. But if you write 1.5 cm per second, yes, you got it wrong. Because what? Because you have the word decrease over here, mean negative. Okay, this is something very important. Alright, and then he asks you, find the rate of change of area. So rate of change of area, whenever you see rate, you know he asks you to find something related to dt. Okay, and then you see area. Area means what? Mean area, mean A. So I will write dA dt. This is what they want to find. You say when the radius equals to 16, when r equals to 16. Alright, so over here, I want to form a change rule very fast. I draw 2 lines, then I put a multiple here. And this one I will write dA, and this one I will write dt. So on the middle, I have to find something in common, which is, I know in this case I have r. So I write r, dr here, dr here. So this one will be the change rule. I'm going to use it later. But before that, I know that I have to find out some information. I have dr dt, but I do not have dA dr. So I have to form this equation by myself. This is the difficult part, because a lot of students can't find the formula by themselves. But most of the time in the exam, the formula is given, so you no need to worry so much. But I think area formula is not that hard for you to actually remember it. Alright, so area will equals to pi r square. This is a simple formula for area. Okay, so I know if I got this, because area of circle. Okay, so I know I can get dA dr easily by differentiate dA, by differentiate this one to r. So it's 2 pi r. And then he said when r equals to 16. So it's simple. So 16 multiplied 2 is 32 pi. Okay, now I got my dA dr. So I can get my dA dt easily, which is my dA dr equals to 32 pi. And my dr dt will equals to negative 1.5. Then of course I use a calculator to calculate this one. 32 multiple 1.5 basically will give me 48. But remember to write negative 48 pi. Because it's very makes sense. You see, when your area, your radius actually decreasing, your area is decreasing also. Like what I say, if the area becomes smaller and smaller, obviously your radius will become smaller and smaller. Alright, so this one must have negative. And then sometimes the student have difficulty to write what unit I should write. So if radius is cm, area of course is cm square. And then per second, right, here they use second. So obviously here use back second. Then you got a full mark for this kind of question. Alright, so far so good. Have any problem or not? If you have no problem at all, I would like you to actually try number 4 now. Okay, I will give you 2 minutes to try out number 4. Okay, try number 4. We will discuss it after 2 minutes. If you have any question or you want to talk anything, yeah, you can just raise hand. I will open your mic and then you can talk. Alright, try question number 4. If forget to write the units, the question will wrong. Okay, if you forget to write the unit, I think you still will get your mark, but maybe you minus half to 1 mark for like no units. Yeah, so it's better to write unit, especially in rate of change. Unit actually is quite important. Okay, so can do it or not? Is it, or you find it like very difficult to understand? Okay, so yeah, let me like actually like erase the thing. Okay, let me like use other color, maybe use purple. Okay, number 4. Okay, have a look here. Number 4. Over here it said the radius of the sphere decrease at the rate. So when you see spheres, you know actually this is you have to know this is something related to the volume, because only volume, yeah, we will use the sphere, but also depends. Sometimes can be sphere, area of sphere. Yeah, yes. You can get the area and volume both. So you have to finish the question. Alright, so he says the spheres decrease at the rate 2 cm per second. Alright, the radius of the sphere. Alright, so at the instant when the radius is 5 centimeter, find the rate of change of the volume of the spheres. Alright, so here actually tell you is volume. Alright, okay, so this question will be slightly different. So I'm going to do A first, because A I actually see volume. So in these cases, the radius will be decreased at the rate, right? So it's simple. So number 4, first thing I sure will write dr over dt, because radius decrease at the rate what? Okay, so will be decrease is negative 2 centimeter per second. I write negative because of the word decrease. Alright, and then he said at the instant the radius is 5. Find the rate of change of volume. Alright, so rate of change of volume, I see the word rate, I know something related to dt. And then over here he said volume, so I want to find dv dt. So first thing is I form the change rule first. I draw 2 lines and then do multiple over here. This is dv, this is dt. And then the middle one must be something in common. In these cases we have r. So this is dr, this is dr. Alright, now I have dr dt over here, which is negative 2. But I do not have dv dr. So in order to get dv dr, you know you must remember what is the volume of sphere. So it will be 4 over 3 pi r cube. Alright, sometimes actually this formula is given by the is given in your exam. Alright, so you don't need to worry so much, but I think it's okay for you to actually remember some of the volume because it's quite important. Alright, so after I got the volume of the spheres. Okay, this is the volume of sphere. This is the formula. Okay, so it's not something actually I like write it out myself. Alright, so it's sphere. Alright, so in order to get dV out, I know I actually can differentiate volume toward the radius. So I move the 3 in front, I will actually get 4 pi r square. And then he give me some information is its radius is 5 centimeter. So r is 5. So I substitute in, this is 4 pi multiple 25 because it's 5 square. So it's 100 pi. Alright, so if I got the information, I can substitute it easily because this one equals to 100 pi. And then this one equals to -2. So basically, I will have -200 pi. And then this is volume, right? Radius is UCM, so volume I will use cm cubed per second. Done. Okay, this is for part A. So part A, you will have your own change rule. And then I believe part B, you will have another one. Because what? I see the total surface area of the sphere. So, in order to do part B, I'm going to erase some of the part here. I just hope you can still do it. Alright, so let me change back to the same color, purple. Alright, B. Oops, sorry. Change back to the same color, purple. Alright, B. So he asks you to find the rate of change of total surface area. That means you have to find rate of change of area. So I'm going to write dA dt. And then over here, I'm going to like form the change rule very fast, which is dA. Draw a line, draw multiple, draw a line. This is dt, and the next one is dr. So you can find out that actually even here I change to dA, I can still use back dr dt. It doesn't affect. Alright. So of course you will realize this one very quickly is you do not have dA dr. You not even have the formula for area. This is sphere, right? So area, what is the area for sphere? So you have to remember area for spheres is 4 pi r square. So this is the area formula. So over here, I can easily get dA dr by differentiate this one. So actually I will get 8 pi r. And then it tells me r equals to 5. So I substitute in, I will get 40 pi. So if I got this one, I can get the answer easily. Wait, I change some color. Okay, I will get the answer easily because what is my dA dr? My dA dr equals to 40 pi. So 40 pi. What is my dr dt? My dr dt is -2. So -2. So obviously this one is -80 pi. And because this is area, right? I know it's cm square per second. Okay, got the idea how to do this kind of question? Okay, because it's quite run out of time, so I'm going to stop here. If got time, I will actually go back to the past year question. Because I stopped here because I want to go to something like small change and approximation. So yeah, something very important is you have to understand the question, and then you have to like form the change rule by yourself based on your understanding. And then in your level, change rule always will have 3 variables. You can find out you have A, you have T, you have R in this case. This case you can see 3 variables. In this case you have V, you have T, you have R. You have 3 variables. Okay? You always like form using 3 variables, then you can write your change rule by yourself. Okay? Okay. So far you have any question? If you have no question, then I'm going to move on to small change. How many marks in exam? Yes, don't need to worry so much. So far, I think this one only come out in paper 1, so which is 3 to 4 mark question in SPM paper 1. Okay? Okay, then I move on to small change. Okay, here I think you actually will have some other question also. Yes, actually all these questions I get from the Pelangi reference book. Alright, so okay, over here now we learn about small change first, then only we go to approximation. Okay, small change it have its own formula also, but the formula is quite simple. You understand about dy dx, right? Okay, if you understand about dy dx, small change is something like this. You will got something like very similar with dy dx, which is I call it change of y. This is something over change of x. This is the only formula in small change. So this is not d, this is something like change of y over change of x equals to dy dx. So you can imagine something like dy dx and dy dx is equal. Alright, so of course you can change a lot of things based on this formula. If let's say I want to find change of y only, so I write change of y will equals to dy dx multiple change of x. I just move this one toward that side. It's algebra, so it's multiple. So let's say if I want to get change of x, I just move this one to the other side. So equal to change of y multiple dx dy. Okay, got the idea? I just flip over dy dx. Okay, so every formula is come from this one. Okay, you must understand about this formula. Okay, and then later I will explain what's the meaning for change of y and what's the meaning for change of x. Alright, so okay, so now we're going to pick some question, and then yeah, I'm going to like teach you about that question. Alright, so for example, okay, question number 8 first. Okay, we'll go to something simple first. Okay, he gives you a cone has the fixed height 8 cm. If the base radius of the cone change from 3 to 3.05, find the approximate change in the volume of the cone. Okay, I think we do not want to go into this question first, because this is already approximation. Okay, let me find some small change question, because straight away go to approximation, I think you will feel very confused. Okay, let me choose some small change question, which is, I think this one is a small change question. Alright, let me see. Find the change of y in terms of k. Alright, this is small change question. Okay, come, have a look this one. Okay, given that y will equals to 4 over x cubed, expressed in terms of k, mean your answer can be has some number with the k, maybe. The approximate change in y. Okay, expressed in terms of k, the approximate change in y when x change from, okay, this one. He said x change from 2 to 2 plus k. Something very important over here is, okay, this is the new value, this is the old value. Because it very makes sense. He said change from 2 to 2 plus k, right? So from old to the new value. So first thing is, I have to find my change of x. I use my new value minus my old value. So my new value minus my old value. So what I will have is, so I cannot see the question. Okay, so do you see something like given a function y equals to 4 over x cubed? Aliang, you still cannot see? What do you mean I cannot see? Is it very blur or you have no idea? Me too, no question I see. Is it? Wait for a while. Can you see the question right now? No? Still cannot see? Okay, see the question right now, right? Okay, good. Okay, so let me continue. So now, if given that function y equals to 4 over x cubed, express this one in terms of k. So find the approximate change in y when x change from 2 to 2 plus k. So very important over here is, you must understand 2 is the old value and 2 plus k is a new value. So whenever I write the change of x, I use the new value minus the old value. So 2 plus k minus 2, I get k. So in these cases, my change of x is k. Alright, so here he asks you to find change in x. So I know I want to find change in x, change in y, sorry. So I know my formula, change in y over change in x equals to dy dx. So what's the change in y? Well, equals to dy dx multiple change of x. So now I got change of x already, which is equal to k. But I do not have dy dx. So this is question asked me to find change of y, right? So I want to find dy dx. Of course, I have to have y equals to x over 4 over x cubed. So I will write in integers form, and then I will differentiate it. So I will get negative 12 x negative 4, which is negative 12 over x power 4. Alright, so now I got dy dx, I got change of x, but I'm not yet finished, because if I want to like get the thing I want, so I will do something like this. Okay, now change of y. What is my dy dx? Negative 12 over x power 4. Multiple change of x is k. Alright, now I got this thing, but the problem is I still got x over here. So remember, the x over here, you always substitute the old values of x. Okay, what is your old values of x in these cases? It will be 2. Do you see the 2 over here? Yes, it will be 2. So over here I'm going to substitute a 2 into that. 2 power of 4 multiple with k. So this one basically is negative 12 over 16 k. And then I simplify, I will get negative divided by 4, 3 over 4k. Done. So over here, after you form the formula, you must get the hints is the x value, you always substitute the old values of x. In these cases, the old value of x is 2. So you just substitute in, then you will get 3 marks. This is past year question. Okay, got the idea how to do small change? For me, I think the small change is the easiest one, because the question won't go until like too complicated. Okay, let's have a look some other small change question. I think I have few here. Okay, this is is this a small change? Or it mixed two? I think this one is the, no, I think this is not the small change. This is small change. Okay, come, have a look this one. Can you see the question? Can you see the question? Can you see the question right now? Okay, good. Okay, over here, you must understand the question first. This is one of the past year question also. Okay, give you an equation, and then give you u equals to this one, and then it asks you to do the dy dx. Alright, so this one actually we discussed in the, if you join the first virtual classroom about differentiation, actually we discussed this one. Alright, he asks you to find dy dx. Okay, actually this is using change rule also. You see what I do. This is dy dx, right? So I will write equal. I draw 2 lines and write a multiple here. This one I will copy dy, and here I will write dx. And then on the middle I will write something in common. Now I got y, I got x, and then I know I have u, right? So this one will be du. It will be du. Okay, so over here I got this one ready, and then of course what I do next is I differentiate the thing. Y equals to negative 4 over u power of 3. So what is my dy du? I just differentiate this one. So this one actually is negative 4 u negative 3, right? So I differentiate, I got negative 3 multiple negative 4 is positive 12 u power of negative 4, which is 12 over u power of 4. Alright, of course because here I dy dx, so later I will do something is I will substitute, I substitute now. What is my u? You got it here, u equals to 1 minus 2x squared power of 4. Okay, this is what your dy. This is later you're going to use this one. But then now you stop over here enough. Alright, okay, so here I got 12 over u power of 4. So I write over here. And then what is my du dx? I have u equals to 1 minus 2x squared. So my du dx, just differentiate this one. Du dx, I will got negative 4x. Okay, I'm going to write multiple negative 4x. Alright, then over here you will find dy dx. I still have u over here, so it's not acceptable. So what I will do is I will substitute my u into the u over here. So which is I already done over here. So which is 12 over 1 minus 2x squared power of 4 multiple. So I straight away write on the top negative 4x. So I just simplified this one. I got my final answer, negative 48x over 1 minus 2x squared power of 4. Done. Alright, it's not really hard. If you understand about change rule, you just write the change rule and then you're trying to get all you want from the information it gives you. If it gives you y and u over here, you know this is dy du. If the question gives you u and x here, you know this is du dx. Alright, then you just substitute into here. Even here you leave in the u power of 4, I think you still will get some mark, but you won't get full mark. Because why? This is dy dx. Means your answer over here can only have x. You cannot have x and u both at the same time. Okay? Got the idea? I hope you do. Alright, so I'm going to erase this one, then I continue to do part B. Alright, part B, maybe I change some color. I change the black. Okay. So, let me change some. Okay, B. So from here, he's asked you to find the small change of y. I know I want to find the small change of y over here. Alright, so I will write the formula for change rule, which is dy dx multiple change of x. Because change of x actually is over here, right? So I move the change of x to this side, become this change rule. Alright, got no difficult, right? And then he say x is increased. Very important, the word increase, mean you do not have negative. So this is the new values of x. And this one will be the old values of x. Because from the old to the new one, it's very common. It's very makes sense, right? So I want to find my change of x first. So my change of x, I'm going to take my new value minus my old value, which is 0.02. It's a change of x. Alright, and then I have my dy dx. I already done here, my dy dx, which is negative 48x over 1 minus 2x squared power of 4. And then I multiple with 0.02. Okay, I multiple with 0.02. Alright, and then you're not yet finished. Why I say you're not yet finished? Because you still have x over here. So what you need to do is always substitute the old values of x into here. Let me repeat this one because a lot of students tend to forget. They just leave your answer over here. See the x here? Substitute your old values of x. Alright, your old values of x over here will be 1. So I'm going to substitute into it. So in negative 48, substitute 1 is just negative 48. This is 1 minus 2, which is negative 1. Power of 4. Multiple 0.02. Negative 1 power of 4 is just give you 1. So it's 48 multiple 0.02. So I press the calculator, multiple 0.02. Oops, 48 multiple 0.02. I will get the answer is 0.98. 0.96, sorry. Okay, so this is my change of y. Then I think this is 4-mark question. So far so good. Can understand this one? It's not really difficult, right? Do you have problem? If I have no problem, I'm going to move on again. Okay, I guess you have no problem. So we're going to move on to some other question. Let me see, do I still have the small change? Okay, this is the rate of change. Alright, let's have a look. I guess some of you cannot see the question also. Can see the question right now? Can you see the question right now? Can, right? If can, then I'm going to move on. Okay. Over here, the question says the metallic cube. So you must very sensitive with the words cube. Because what is the meaning for cube? Cube is the box with the same side, right? This one we call it cube. Alright, with the side with x. So he have the length with x, x, and x. Alright. So expand at the rate 2.7 centimeter cube per minute. Alright, find the rate of change of x. So over here, first from this sentence I already got some information. He asked you to find dx dt. Because I say rate mean dt, x mean x. Alright, he asked you to find this one. So over here, I must like, I know I have x here, I have t here. And then from the Cn cube here, I know I need to have volume. Alright, so I randomly give a volume by myself. So volume will equals to, what is the volume for cube this one? X multiple x, which is x cube. Okay, this is something you must get it by yourself. Alright, so, alright, and then this one, he said the cube made of the Cooper with a sine x cm expand. So this one actually is the cube expand, right? So this one actually is dv dt. If you can't get dv dt equals to 2.7 cm cube per minute, what you can do over here is actually, you understand from the unit it gives. You see cm cube, you write dv. You see per minute, you write dt. So obviously this is dv dt. Alright, now I got v, I got t, I got x, so I can form the chain rule easily. I draw two lines, I write multiple here. So this one I copy the top one, this one I copy the down one, bottom one. Alright, so the middle one obviously is v. Alright, dv. Okay, now I got my change rule already. And then I have dv dt, which is 2.7. And I do not have dx dv. So I want to find dv dx first. I differentiate dv dx, which is what? 3x squared. Okay, 3 move in front, minus 1. So, but I do not want dv dx. I want dx dv, which is I have to flip over. This is over 1, right? So this is 1 over 3x squared. Okay, I almost done. Here he give me some information when the x equals to 4 centimeter. So x equals to 4. I substitute into here. It's 1 over 3. 4 squared is 16. So it's 1 over 48. Alright. Then now I got dx dv. I got 2.7. I substitute in. This is 1 over 48. This one will be 2.7. Alright. Then I just multiple them. So it's actually is 2.7 over 48. Calculator tell me that it's something like 0.05625. Alright, this is x, right? X is actually just a cm. And then this one is per minute because the question doesn't use second. Done. Alright, this is one of the past year question. I hope you can get some idea how to do this one. Alright, because we have so limited time, so I'm going to move on to the last part, which is the approximation. Approximation is almost like never come out in SPM. I only see the approximation come out once within so many years. So over here, we're going to discuss about approximation, which is, yes, I come back to this one. Okay, approximation is something like, he asks you to estimate this value. Is estimate this value, oops, I guess some of you cannot see the question, isn't it? Can see the question right now? Can you see the question? Yes, right? Okay, good. Okay, approximation is, he asks you to like estimate this value without using calculator. Of course, you can use calculator like 27 over 2.96 power of 3. Then you will got some decimal value over here. But what you learn in approximation is you're going to get this value without using calculator. This is what you learn in approximation. So I'm going to teach you how to solve this kind of question. But before that, approximation have its own formula. Alright, the formula is also very make sense one. Okay, the formula is like this. I want to get the new y value. Okay, I must from my old y value plus my change of y. Is it very make sense? So let's say my old y value is 2. My change of y is 0.02. So 2.02 is my new y value. So you can get some basic idea about this one. I believe this formula is given also in the exam. I'm not sure, I have to check back the formula list. So you just need to remember this one. New y value will equals to old y value plus the change of y. So because the old y value, you plus the change of y, you already get the new y value, isn't it? Okay, I hope this is not something like impossible for you to understand, because I'm going to move on this one very fast. Alright, so over here, he give you this one, y equals to 27 over x cubed. Alright, and then he tell you x is 3. So over here, I must write in the same pattern in order to make you understand. But I prefer use other color. Okay, let me use some other color. Okay, what? Sorry, I haven't changed the color. Okay, so over here, y will equals to 27 over, he said x is equal to 3, right? So I'm going to put the 3 into here. Cube. And then he asked me to approximate this one. I assume this is the new y value. This is O1, because the first thing he give you is the O1. Now it's the new one here. It's 27 over 2.96 power of 3. So from here, do you see the pattern among them? So first is, this is x value, 3 is the x value. So you actually see the x value from 3 change to 2.96. So that's why I say I must write in the same pattern in order to make you can able to see it. So you see 3 to 2.96, obviously 2.96 is the new x value, right? So over here, I come out a conclusion. I get the new x value. I can get the change of x. So will be new x value minus my old x value, which is I will get 0.04. This is the first information I get. But then you will find out that if you get this value, actually doesn't help much in this formula, because the question does not want change of x. The question only want change of y. But because you learned the formula just now, you know change of y equals to dy dx multiple change of x. So you can get, from this formula, you can get change of y. So over here, I must have my dy dx. So please let me do the dy dx very fast. This is x power negative 3, right? So I differentiate this one. My dy dx will equals to negative 81 x power negative 4. Alright, I call it negative 81 over x power 4. What is my x now? My x actually is equals to 3. So it's 3 power 4. 3 power 4, press the calculator, it will tell you it's negative, it's 81. So this one actually gives you negative 1. So my dy dx is negative 1. Because I solve on the top there. And then this one, oops, where's my 0 here? My top here, this one is 0.04. Alright, oh sorry, this is negative 0.04. This is negative 0.04. Alright, so negative 1 multiple negative 0.04, I will get back positive, right? So I will get back 0.04. This is my change of y. You always need to find like this. So you must, because the question always will give you the change of x first. It won't straight away give you change of y. Because the question loves to give you something more to do. He loves to give you something more difficult. So you must understand actually you can do like this. Why my alphabet missing itself? Am I pressed something wrong? Okay, so now I got my change of y ready. First information I got. Okay, I'm going to substitute in here, which is 0.04. Now I want to find my old values of y. This is my y. This is old values of y. So what is my old values of y? Will be 27 over x cubed, right? My x is 3. 3 cubed, 3 power of 3, which is 27 over 27, which is 1, plus 0.04. Therefore, you estimate this value. Therefore, 27 over 2.96 power of 3 will give you 1.04. Alright, this is the final answer. However, we always want to check whether this answer is correct or not. So, if you have the calculator with you, please take your calculator and press it yourself. So, what I want you to press is, you press 27 over 2.96 power of 3. I'm not sure whether you can see my calculator or not, but I think it's quite hard for you to see. Yes, do you see that? And then I press equal. you'll find out that I actually will get 1.04. Yes, this is how we get 1.04. Okay? Yes, this is what we call it approximation. This one actually is combined small change. It's combined dy dx. He combined, yeah. Sometimes it's always combined rate of change. So approximation actually is somehow more difficult compared to rate of change and small change. I would say the small change is the easier one, and then is after that is rate of change. After that is this approximation. Of course, in the last virtual class, actually I teach about paper 2, right? Yeah, please do more practice on paper 2 because it actually gives you a lot of mark. You just need to understand about tangent and normal. Alright, I think, yes, I almost want to end the class already. You have any question you want to ask? Or like any part you just feel very confused, or like any part you like cannot understand at all before I end my class? Yes. Any question? More example? You want more example for approximation? Or for any other topic? Yes. Yes, approximation. Last class is about. Last class actually, what you learn is actually the differentiation, but for paper 2. Mean for in SPM MX exam, the differentiation will come out in paper 2 as well. So last class actually we discussed about that. You can find out the video in my YouTube channel also. Okay, let me like take one more approximation example, like make sure you can understand what is going on. Let me see, do we still have approximation over here? Yeah, I think at the beginning there. Yes, I think not this one. This one is rate of change. Where's my approximation? Okay, it's over here. Okay. Let me like find some of the example. Okay. Can you see the question over here? Okay. Yes, good. Maybe we have a look on the question number 10. Oh, have a look question number 10. Alright. So first, let me write out the y equals to 125 over x cubed. And then over here it tell you x is 5. So I'm going to like do some comparison first. Actually, we're very familiar already. You no need do like me. You can straight away do. And then it give you the approximation is this one, 5.02 power of 3. You can see actually both of them is the same power, right? So this one will be OY. This one will be my new Y. Alright, so from here, some information I can get is change of x. Because this is actually x, right? So take the new value minus the old value. Remember, this is something very important because I got students just simply take one to minus the other one. No, if you're old, it is very dangerous. So take the new x minus the old x. This is something very important. Don't simply take one value to minus the other. The negative will make your whole question wrong. So this one will give you 0.02. Okay, positive. This is positive. Alright, get the idea already. I'm going to erase this part because I'm not going to use it now. Alright, then of course the formula tell you what? New values of y will equals to old values of y plus change of y. Correct or not? Now you got change of x. You know you have to find change of y. So we will find change of y. So I know actually I want to find change of y. The first thing I do the dy dx first. So y equals to 125 x power of negative 3. Then I do dy dx. Because this one going to be used in change of y. So it's negative, wow, this number is quite big. So 125 multiple 3 is, let's use calculator will be better. 375. This one will be negative 375 x power of negative 4, right? So over x power of 4. So I got my x over there. My x actually is power 5. Is 5 power 4. Because x is 5, right? It's given over here. Alright, so let me press the calculator. 5 power is 625, right? Yeah, it's 625. Wow, it's very fast. Is it? Let me press the calculator. Negative 375 divided by answer. Yes, thank you. Negative 0.6. Okay, this is negative 0.6. Alright, so now I can find my change of y easily because I know it's equals to dy dx multiple change of x. So dy dx is what? Dy dx is negative 0.6. Multiple my change of x is over here, 0.02. 0.02. Then press the calculator. I believe you have got, negative, 0.012. Alright, now you got this one. Okay, change some different color. Okay, I got this one, negative 0.012. Okay, I want to find my O values of y. Okay, O values of y is quite simple. This is the O value, right? You just substitute the 5 into that. So you got 5 cubed. 5 cubed is 125, right? 125 over 125 is 1. So O values of y is 1 plus this one. Alright, so press me the calculator, see what answer you got. So basically this is 1 minus 1 plus answer. Yes, you will actually get, 0.988. Alright, approximation, the good thing about approximation is you always can take back the answer. So let's press the calculator. 125 over 5.02 power of 3. See whether you can get 0.0988 or not. See whether you get this answer or not. Use your calculator to press it yourself. 125 divided by 5.02 power of 3. Are you getting 0.988? Yes. Yeah, of course you won't get like all decimal. Yes, so you get this one, you already correct. Yes, I think for approximation, the exam will give you 4 marks. Alright, actually it's not that hard. And then here actually I have few more example. So actually like 11 is the approximation also. You can try to do it yourself. And it's not mistaken, I'm not sure. 12 and 13 I think is related to approximation, but then it's like quite hard question. I don't think it will come out in SPM, but yeah, if you have time you can try it out. All the question over here. Okay, so far any more question before I end the class here? Yes, you can try, and then if you still have any problem you can find me in Facebook. I would love to help you if I have time. Any more question? If not, we're going to end the class right now. Alright, then that's all for the class today, and yeah, thanks for participating. Yeah, I will see you soon. Yeah, maybe we have class next week. And this Sunday, actually, I will discuss about this part again on this Friday. Yeah, this Friday, blah. I will discuss the same class again on this Sunday. But the Sunday, because few students actually asked me about the probability, so I will have the Mandarin class about probability on this Sunday. But only for those students who can understand Mandarin. Yes. So yeah, so if you have any question, yeah, please find me in Facebook. And if you have time on this Sunday, I think it's 7 to 8 and then 8 to 9. Yes, yeah, you can participate on this Sunday also. One class is for MX and the other class is for Modern Max. Anyways, thanks for participating. Bye bye. See you soon. Bye bye. You can leave now. I'm going to end now. Bye bye.